Students, today we are going to learn how to multiply and divide complex numbers in polar form. For this operations, we have lovely theorems that we are going to use but not prove. The first theorem says if I have Z1 equals to R1, cis theta 1, and Z2 equals to R2, cis theta 2, then Z1 times Z2 equals to R1 times R2, cis theta 1 plus theta 2. So it says, the theorem says, you are going to multiply your modulus and add your arguments when you're multiplying complex numbers in polar form. When multiplying complex numbers in polar form, we are going to multiply our modulus and add our arguments. Now, with regard to division, if I have the same Z1 equals to R1 cis theta 1, and I have Z2 equals to R2 cis theta 2, then Z1 divided by Z2 is going to be equals to R1 divided by R2 cis theta 1 minus theta 2. So in this case, we are dividing the modulus and subtracting the moduli and subtracting the arguments. Going straight into an example. Calculate 2 cis 60 times root 3 cis 45. Same thing, both polar form. So what am I going to do? I am going to multiply my moduli. Cis, I am going to add my arguments. And this gives me 2, the root of 3, cis 105 degrees. Just like that. It's the nicest theorem ever. Makes life so much easier. All right. We are going on to, what about division? So we said with division, we divide our moduli and we subtract our arguments. So if I have 2 cis 90, 6 cis 30, what I'm going to have is 2 divided by 6 cis 90 degrees minus 30 degrees, which gives me 1 over 3 cis 60 degrees. I will leave it there for now. Sometimes you'll be asked to write in decimal form or leave in finite form, but for now we'll just leave it here. All right, that's how easy it is. Now let's see how they can try to make it complicated, try to make our life hard, but we got this. Okay, let's see. Cis 22,5 degrees times 5 cis 67,5 degrees over the bottom there. All right, the first one, they are both in polar form, and we can see that we are multiplying. So we use our first theorem. We are going to have multiply our moduli, our r's. So it's going to be 1 times 5. That's going to give you 5 c's 22,5 degrees plus 67,5 degrees. Okay, that's the rule used on top. Let's look at the denominator. 3 squared is 9. I don't know why they're trying to trick us, but it's 9. Then cos 12 degrees plus I sine 12 degrees. If you look at this thing, this is just the expanded form of the polar form. So we can bring it down so we can use our rules. So it's going to be literally 9 is 12. That's it. 9 is 12 degrees. All right, let's go on. Add what we need to add. This gives us 90 degrees over 9 is 12 degrees. All right, then you have your 5 divided by 9. I can leave it as 5 divided by 9. If I'm to leave it in decimal form, it's going to be 0,5 recurring. So it's going to be 0,556 in 3 decimal places. Then C's 90 degrees minus 12 degrees. So it's going to be 0,556 C's 90 minus 12. That should give me 78 degrees. This one has an extra instruction that we are supposed to leave in standard form. So meaning now it's in polar form, we need to change it to standard form. That's easy. Expand the polar form to the main one. So I'm gonna have my modulus into cos 78 degrees plus I sine 78 degrees. Then multiplying out, this needs a calculator, times cos 78. That gives me 0,116 plus, then the sine 1 gives me, sine 78 gives me plus 0,544 I. And there you have it in standard form. My encouragement is try these things again, the examples again, get your own, practice, 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 for practice will make perfect. Shalom.